Hey everyone, it's Justin again. Previously, we learned what a function is, and we learned what domain and range look like on a graph. In this video, we're going to be finding the domain of functions algebraically instead of graphically. When calculating domain algebraically, we find what is known as a domain restriction. These are just inequalities representing which values can or cannot be used as the inputs in a function. If the domain restriction for a function is x greater than or equal to 3, then all values 3 or above can be used as inputs, and any value below 3 cannot. Every function has a domain. Some domains are restricted to only one input, and others have domains that aren't restricted at all and span the entire number line. Each function is different, so it's important to know how to properly calculate a function's domain restrictions. Most functions, though, don't have any domain restrictions, meaning that any input can be used. But there are a few features that can cause a restriction to occur. We're going to focus on two of these: denominators and square roots. When a variable appears at the denominator of a fraction, this causes a restriction. Here's an example of the variable in the denominator of a function. The other major domain restriction occurs with square roots. When the variable appears under the square root, there's probably a domain restriction. Here's an example of a variable under a radical. Both of these situations indicate that the functions have domain restrictions, which we'll have to calculate. For a variable under a denominator, the rule is that the denominator can't be equal to 0. So the way we would find the domain restriction of this function is by taking the entire denominator, setting it not equal to 0, and then solving. In this case, solving it's super easy. You just subtract 2 from both sides, and we get that x is not equal to -2. This tells us that every number is in the domain of this function except -2. But why? What's so bad about plugging in -2? Let's try it. We input -2. -2 plus 2 is 0, and 3 divided by 0 is... Oh. So that's why we can't input -2. Division by 0 is impossible. This is what domain restrictions do. They keep us from using an input that results in an impossible output. As long as we don't input -2, we'll never have an issue with this function. As for square roots, the rule is that the radicands, which means the part underneath the radical, has to be greater than or equal to 0. So to calculate this domain restriction, we take the radicand out of the square root, set it greater than or equal to 0, and solve. To solve this, we add x to both sides, then flip it over so it's easier to read, and we get x is less than or equal to 12. In other words, the domain includes all numbers 12 and below. But why can't we use anything higher than 12? Let's try using 13 as the input. 12 minus 13 is -1, and the square root of -1 is... that's why. If we use an input bigger than 12, we end up with the square root of a negative number, which isn't possible. So again, the domain restriction told us what inputs do work with the function, while telling us not to use the ones that won't. To recap, if the variable is in the denominator of a fraction, you find the domain restrictions by setting everything in the denominator not equal to 0. The results will tell you what numbers are not in the domain because they would cause a division by 0 error. If the variable is under a square root, set everything under the square root greater than or equal to 0. The results will tell you the interval of numbers that can be the input and excludes all the inputs that would cause you to square root a negative number. Domain restrictions are super important because they keep you from accidentally using an input that isn't possible. In the next video, we're going to do some more difficult examples of domain restrictions. See you then!